Hello, my dear students. Today's lecture is about Introduction to Microprocessors and Microcontrollers. The main focus for this lecture is 1. Components of a computer. 2. CPU, Central Processing Unit. 3. Differences between microprocessors and microcontrollers. Components of a computer. A computer system is generally made up of a few major components. The first component is the Central Processing Unit, CPU, or brain of the computer. It is a collection of logic circuits that fetches and executes instructions. The second component is memory. Memory can be in terms of random access memory or read-only memory. The third component is buses. Buses are a collection of wires carrying information with a common purpose. There are three major types of buses. 1. Address bus, which contains address of the location of data or instruction. 2. Data bus, which carries information between microprocessor and memory, or input-output devices. 3. Control bus, which are a group of signals, each with a specific role to control the activity of the computer. The fourth and last component are input-output devices, or peripherals. Example of these are monitor, keyboard, mouse, motors, relays and sensors. Now, put everything together in a block diagram. You would have the CPU connected by address, data and control buses to memories, and also input-output devices. The CPU. The CPU consists of smaller component, namely the program counter, instruction register, arithmetic logic unit, or in short ALU, instruction decode and control unit, and some registers. The ALU consists of many logic gates. Its main operation is to perform arithmetic operations, like additions, subtractions, multiplications, and divisions. It also performs logical operation like logical AND, logical OR, and logical NOT. The instruction decode and control unit determines the operation to be performed and prepares for it. Registers serves as temporary memory. It consists mainly of flip-flops. The instruction registers holds the binary code, or machine code of the specific instruction. The program counter points to the address of the next instruction. Note: instruction sets are used by us, as humans, to tell the microprocessor what to do. A series of instructions combined to perform a meaningful task is called a program or software. CPU operations. There are four main steps that the CPU uses in its operation: fetch, decode, execute, and write back. Fetch involves retrieving an instruction which is represented by a number or sequence of numbers from program memory. The location in program memory is determined by the program counter, which stores a number that identifies the current position in the program. In other words, the program counter keeps track of the CPU's place in the program. After an instruction is fetched, the program counter is incremented by the length of the instruction word in terms of memory units. The instruction is then stored in the instruction register. Often the instruction to be fetched must be retrieved from the ROM. Here is an example of how instruction fetch is performed. When the CPU is first powered on, the program counter and instruction registers are all zeros. The first instruction is an address location, 0000 hex. It holds E9 hex in its memory. Or in assembly language, move R1 to the accumulator. During the fetch phase, the CPU will go to address location 0000 hex and store E9 hex into the instruction register. Then, the program counter is incremented to point to the next instruction, which is 0001 hex, which holds 29 hex. The similar process will then continue until the end of the ROM. Then the program counter will reset back to 0000 hex. In the decode step, the instruction is broken up into parts that have significance to other portions of the CPU. The way in which the numerical instruction value is interpreted is defined by the CPU's instruction set architecture, ISA. Often, one group of numbers in the instruction, called the opcode, indicates which operation to perform. The remaining parts of the number usually provide information required for that instruction, such as operands for an addition operation. We use back the example from the previous slide. After the fetch phase, the instruction in the instruction register is decoded. E9 hex will be decoded to tell the ALU to perform an addition. The decoded instruction will also tell the memory to grab data from R1 and to store back to the accumulator. Similarly for the next instruction, 29 hex will be decoded to tell the ALU to do an addition and also tell the memory to grab data from R1 and the accumulator and to store back to the accumulator after the execution. After the fetch and decode steps, the execute step is performed. During this step, various portions of the CPU are connected so they can perform the desired operation. Again, from the previous example, after fetch and decode, the ALU will execute the operation. The first instruction is to add contents of R1 with nothing and store it back to the accumulator. The next instruction is to add contents of R1 and accumulator, and store it back to the accumulator. And the last instruction is to add contents of accumulator with nothing and store it back to R2. The final step, write back, simply writes back the results of the execute step to memory. Very often the results are written to some internal CPU register for quick access by subsequent instructions. Now that we have the complete process, after the execute step for the first instruction, 03 hex, is written to the accumulator during the write back step. Similarly for the second instruction, 06 hex, is written to the accumulator. And the third instruction, 06 hex, is written to R2. Microprocessor versus microcontrollers. Differences between microprocessors and microcontrollers. Both have the arithmetic logic unit, registers, interrupt circuits and clock circuits. However, the microcontroller has more components, such as internal RAM, internal ROM, timers, and input-output ports. From the hardware architecture point of view, the microprocessor contains only the CPU. It cannot be used as a standalone device, as it requires buses, memory and input-output devices, to become a computer system. In short, it is just a CPU on a chip. Whereas the microcontroller contains the CPU, plus other components of a computer system. In short, it is a computer on a chip. The microprocessor is mainly used to process information. It is also used to run general-purpose applications. The microcontroller, however, is used in control-oriented applications. The instruction set features for the microprocessor is more processing-intensive, so it can handle large volumes of data. Whereas for the microcontroller it is more control-intensive to handle control of input-output devices. We have come to the end of today's lecture. Stay tuned for the next chapter.